So now we want to look at what our TI can do for us in the sense of graphing these conic sections. So we're going to go with a previous example that we may have done by hand, and we're going to use our TI to graph the equation x plus 3 squared plus y squared equals 16. Now, before you could enter anything in the TI, remember the whole idea is to solve your equation for y. And in our case, the first idea that we'd have to go across is to make sure we isolate the y squared first. So that can be done by subtracting x plus 3 squared from both sides. You don't necessarily have to show this step, but sometimes it helps with some of the details along the way. So that's going to leave us with y squared equals 16 minus x plus 3 squared. And now if we're solving for y, we have to undo the square. So in order for us to do that, we will take the square root of both sides. And remember, if you take the square root of both sides, we have the case where we have to end up using a plus or minus symbol. And we'll discuss that in a second. So the square root of y squared, for purposes of shortcut, we're just going to say that this is a y. And then with the plus or minus, I'll keep that in. That will leave us with no need to simplify at all. Actually, we really can't do much, so don't bother. I have x plus 3 squared. So 16 minus x plus 3 squared, all underneath the radical. Right, Laika? Yeah, okay. So what's going on from here is we're going to notice with the plus or minus sign that this actually breaks this up into two equations. So we're going to look at this as y equals the positive case, 16, square root of 16 minus x plus 3 squared. And y also equals the negative case. And I'll draw that in red just to, oh, I meant red. There we go. Square root 16 minus x plus 3 squared. So what we'll do is instead of calling them both y, one of them will be y1, and then we'll make the other one y2. And I'll probably go with the color codes I see in my TI from there. So we're going to pull up the TI for ourselves. And what we're interested in doing is pressing the y equals to help us out. Let's see if I can get the screen to show on the side for you all. There we go. That's much better. You didn't see that, but I did. There we go. Okay. So what we'd like to press, I press the y equals button. And again, with the y1, what I'd like to do is press the square root. So second square root of 16 minus, and that's going to be the quantity of x plus 3. And don't forget to raise that to the power of 2. So I'll press enter. And then I can enter the other version where we have the negative square root. So just a kind of a quick reminder, when you enter a negative symbol or sign, it's always the symbol right by the enter key, not the minus sign. Sometimes if you enter the minus sign, you just get an error and you can go back and fix it. So no problem there, but I like to warn you ahead of time. So we're going to enter the square root again, second x squared. And the radicand should be the same. So 16 minus the quantity of x plus 3. Don't forget to square that quantity. And then I want you to watch what happens when we graph. So notice that the y1 was in blue, the y2 is in red. And you kind of see like, oh, okay. So it is making a circle. Again, remember what we called the y1. When you have the positive version of the square root, you're actually getting the top half of the circle. And the y2, when you have the negative version of the square root, you're actually getting the bottom half of the circle. So together they make the full circle. And just kind of a few notes. I know you're saying, I thought this was going to be a circle. It looks more like an oval, or you'll later learn ellipse. And it really just has to do with the viewing window of the TI. It's kind of like when we view our TVs. We're looking at like widescreen right now. So if you really wanted to see the true part of the circle, you could actually zoom it to square. This is just for preference if you're looking for visual, and that kind of looks more like a circle for you. So it's kind of like full screen versus widescreen if you're ever watching a movie. That's something to think about. The other issue I want to kind of point out, when you do use your TI, when you're using the two separate equations, sometimes the TI is not connecting the circles, the two semicircles. Just kind of chalk that up to kind of a lack of technology that from the TI, and just kind of understand, we do know that they will connect. So what I'd like to do, I'll just take a quick screenshot here, and then I'll go back to see what the directions were. All they wanted us to do was graph it on the TI and just verify it. So I can do that. And they just want us to see that, is it the same as our graph by hand in the previous example? So what I'll do right here is I'll paste the picture. Whoops, I guess it's not working for me this time around. I guess I'll have to X that out. Sometimes it doesn't quite copy over. So let's see if we can do that. I'll try that one more time. Copy. And let me see if I can paste on top of stuff now. You can see my cues on the side. Let's see if this works again. Oh, just not working for me today. Okay, so I guess we're going to have to just go back to our graph, and I'll see what I can do to fix it, but I'll switch back and forth with the screen so that you both can see. So there's our circle by hand. Notice my drawing with a little shaky, but if we do go back to our TI, I hope that you can see, maybe you were playing along, that we do have the same circle, top half versus bottom half. So just one more time, I'll switch back. We kind of see, yeah, we do have this. So that's all I really wanted to do. It's more of just making sure you're okay with the algebra. It's not necessarily like, to me, I kind of feel like graphing a circle with a TI is more tedious than it is by hand. Mainly because it involves more algebra and there's more of a chance we make a mistake. But later on, when we get to chapter 7, you may want to have these this down where you're able to graph a circle or a conic section on a TI, because it could help you solve those nonlinear systems of equations graphically. So we're just kind of warming you up for then. But until then, if you kind of do what works better, I kind of prefer graphing by hand personally. So I hope this helps. I'll see you in the next example.